Okay, so welcome to our talk. It's called How We Failed and What We've Learned. It's not a strictly technical talk, but more kind of storytelling and best practices. So the talk is divided in three parts. First, I will give an intro about the company, what is TESTABLE, what is Raumfeld, and then tell some stories, what went wrong, and finally some learnings, what works for us long term. Okay, yeah, that's me, my Twitter account, and I work at TESTABLE for more than 6 years, and I spend most of my time working on the iOS app. And TESTABLE was founded nearly 40 years ago and started as a company selling components for loudspeakers, so you could mail order the sets of components and build your own loudspeaker. But not everybody or not all customers wanted to build their speakers themselves, so we started selling pre-manufactured loudspeakers. And 20 years ago, we opened our web shop. Today, TESTABLE is Europe's biggest manufacturer of loudspeakers, and what is special about TESTABLE is that we are a direct manufacturer, so we develop, build, and sell products directly to customers, and there's no merchant in between. And the portfolio is not only loudspeakers, but also home cinema systems, headphones, streaming speakers. So everything that plays audio. Raumfeld was a multi-room audio startup founded in 2008 in Berlin. And the idea was to have a streaming speaker in every room of your house. And they had a first system on the market by end of 2009, and end of 2010, TESTABLE acquired Raumfeld. So the company is gone, but the brand is still there. And in the picture you can see one of the first systems we sold. There was a pair of speakers, a streaming box. You could connect it to your home stereo system with some kind of NAS. And a thing we called controller, which was a remote control, and it was a total custom hardware built with a custom display and own UI toolkit and a giant volume knob. And this was a remote control in the face of the stereo system. And the remote control was mandatory. And alone, this piece of hardware was like 400 euros, so a bit expensive. And even if you only wanted to have one pair of speakers, you needed to buy the remote control. So it was pretty obvious we needed an app to control the playback, and this was a goal. Only one pair of speakers and the app to control the speakers. So we wrote an app. Okay, this leads to the second part of the talk, our fails. To move it across. So we wrote an app and it went wrong. How could this happen? The controller you see on the left side was kind of the blueprint for the app. Not only the UI looked similar, we also adapted kind of the architecture and the inner workings. And the reason is most of the logic for playback happens on the speakers, in the firmware, but the controller has to do some logic for playback. And this makes the whole system a bit complex. So, in order to have a quick app release, we just port this logic from the controller to the app. So it was easier for us because things with the same name worked the same on both platforms. And that one singleton that was used in the controller was also ported. And yeah, we were really quick, 3 or 4 months with 2 people. It was a big success, and yeah, we were happy. We shipped it, we did it, customers were happy. But an embedded system like the controller and an app is different. So the embedded system runs for weeks, one process. But the app is killed multiple times per day and is launched again and again, and we have short interactions. So customers were happy with the iPhone app, but iPad users were not happy, so obviously we need to extend the app to an universal app. And that was the time before auto layout and all the stuff was available. And we had some time pressure, but luckily there was a budget. We could hire people to help us to speed up the development of the iPad app. And what happened? They did not know the original controller implementation and its architecture, and they got a bit confused when looking at our iPhone implementation. So yeah, you see a typical use case when using the app, browsing content. You want to browse content, select music for playback. And the API for browsing this content and displaying, for example, a list of artists in your music collection was, again, complex. And it did not fit really well to a typical table view or collection view data source requirements. And the first time when someone is using your API, you realize how complex it is, just by the questions people are asking you. And they ask a lot of questions. And another problem was that every new developer we put on the project needed some kind of bootcamp for the API, and they needed to learn all the pitfalls and details. So this was our iPad UI. It was different than the phone UI. And so we ended with different classes for the same stuff, depending on phone and tablet. So, oops, duplication. And we did not enforce a specific architecture, or just put it in other words, we had no architecture. We had just a bunch of view controllers and some classes that were doing business logic. So, but we had a release, it shipped, everybody was happy, customers were happy, management was happy, yay. Yeah, meanwhile we implemented more music services, added more features. Some features had to be added twice. One time for phone, one time for the pad. And some features introduced different code paths, depending on the device. So, for example, if you see these 3 view controllers marked here, every view controller contained business logic, classic, yeah? And every view controller interacted with the system, which causes changes to other view controllers. So, for example, you start playback, and this changes the state of the system, and this event back to all view controllers, and the original controller that introduces this change is expecting this feedback, but other view controllers don't. So we needed some strange workarounds to make it happen, but it was not really great. So we had bugs that were easy to reproduce, but super hard to fix. And that slowed us down. But one day MESSIAS approached, and that was a testing MESSIAS. And he was from the Java world, and he taught us to write tests. And we thought, yeah, cool, let's do it. We were really serious, and we thought, okay, it would be great to enforce tests. We measure coverage and build fails if not 90% of new code is covered by tests. That's a high barrier, but we were serious. So, if you write new code and push it, and the coverage was below 9%, the build failed, and you had to write tests until you reach the coverage goal. This was complicated because everything was wired with everything, so it's really hard to test such code. And refactoring is also super hard because it's complex and you can break stuff, and we are risking regressions. And the MESSIAS told us, yeah, use mocking. Mocking is the solution. So we mocked everything. And months later, we experienced some random failing tests. And this was strange. We looked into it, and after some research, we identified two reasons. Problem one was singletons. Surprise. They live as long as the app is running, and the app is running as long all tests are running. So one singleton is living for the whole time when a test suite is running. And the problem was singletons were essential for the app. We could not just refactor them out. And problem two was mocking itself. When you mock classes in Objective-C and forget to tear down the mock, you get problems. Not now, but tomorrow. And this was also biting us. And so we had randomly failing tests, and our development was even more slowed down. And another interesting discovery were a thing we call bullshit tests. Just to increase the coverage, code without logic was tested. So we basically paid people to write pointless tests. And we had to maintain these tests. Yeah. Great that you feel our pain. Okay, can it get worse? It can. It looks like we learned nothing so far. Because there was no time to look back. The stack of tasks on our desks was growing all the time. And there was a wish from the marketing guys. The app looks a bit old-fashioned. Can we put a bit of paint on it? Can we make it look nicer? And we thought, okay, maybe we can do something about the architecture. Maybe we can not only apply some new icons and colors, but also fix the architecture a little bit. But the budget was tight, and it was not enough for doing both iPad and iPhone. So we had the budget for the iPhone, but the requirement: don't break the iPad, don't change the iPad. Okay, problem: phone and pad shared a lot of code, and how to untangle this. Sometimes it is not possible. The solution was wrap everything in another layer of code. So, yeah. Okay, as a result, we got an unmaintainable app, and massive view controllers were the least of our problems. We had a universal app, but features needed to implement twice for pad and phone, and we had multiple, sometimes different code paths for the same thing. And we had all kinds of bugs, strange bugs, random bugs, time bugs, logic spread all over the app. Of course, regressions. Everybody was unhappy, customers too, because they waited forever for new features. And in this picture, there's my all-time favorite comment from our code base. I will read it out loud. Note, the current track metadata change event must be handled prior to the current track URI event. Otherwise, RFI 1558 will occur, which is a side effect of a workaround for RFI 1038. Yeah. Okay, so our receipt for disaster is to have no architecture. And in retrospective, we know that every decision was made with good intentions, but we never looked back, we never corrected our decisions. And of course, as classic ingredient, we had time pressure and feature pressure. Like feature X was promised to someone, but nobody was asked. Not QA, not development, not PO, not UX. And last but not least, our willingness to compromise on quality was also an important factor. We accepted bad code in favor of a quicker release. So, yeah, this was what went wrong. Now I want to share some learnings and yeah, you don't. I share this. You don't have to make all our mistakes again. Okay. Yeah, that's a key learning. A good architecture is a guarantee. It's not a guarantee for success, but a bad architecture is a guarantee for failure. Could be from me. And yeah, obvious. You need a good, solid architecture. But more important, which architecture you pick is that you pick one and stick to it. And you should be really passionate about it. We picked Viper more by accident, and it was not a decision from the beginning, but first we adapted just the good parts we really liked. That was a view model presenter thing. And what is really nice about Viper is that every view controller has the same architecture. That is totally boring, but you can spot immediately violations of the architecture. You see, okay, there's logic in views or in view controllers, or there's logic in the view model. This should turn on a red alert, and you should immediately move this logic into the presenter. So, but what is logic? And we had a lot of discussions about this, and it boils down to all code that contains if or switch is logic, and belongs to the presenter and needs a test. But to clarify, this relates to business logic. There's another thing we call view logic that can stay in views and view controllers. But views and view controllers should not interpret or decode the view model. They just should apply the properties from the view model and do nothing. And this is really hard to enforce automatically, and so the review is an important part to catch these problems. So, yeah, Viper allows really testable code. That's great, because you can test the presenter by just verifying the view model, which is a struct, for example. It just checks the properties of the view model if it's correct. And the view itself can be tested with snapshot tests. And the great thing about snapshots is that you see problems immediately without checking the code. You just observe the diff in the pull request and see immediately if there's auto layout constraint broken, or word wrapping is not working, controls are missing, calls are wrong, fonts not appropriate, image resources missing in language. They need a bit of maintenance, but it's worth the effort. I spot basically every week a problem using snapshot tests. But you should not stop at the UI layer. Make sure you have a solid threading model, which is super important. And make sure you have a nice, clean, solid architecture for your business logic. And make sure it stays the way it was intended. That's how you can make sure that the code does not turn into pasta again. There are invisible boundaries, but there's a tool to enforce these boundaries, and this tool is your compiler. Okay, but how? Frameworks. This is nothing new, but splitting code into frameworks worked surprisingly well for us. And what is absolutely great about this? The compiler enforces your architecture. Before we had all these layer violations, like developer observed the app in the debugger and observed, okay, there's this property when my problem occurs, and I can observe this property and do whatever. But this leads eventually to spaghetti. So all business logic, all networking, model parsing, JSON processing belongs to a framework. And if you talk to two different backends, have two frameworks, and maybe a third one as a common layer as interface for the developer. And the result is, there are no shortcuts anymore. Everybody, you, external developers, whoever, has to deal with public interfaces you provide. And if these are not sufficient, you have to refactor and you're forced to rethink and refine your API. In my opinion, this is the key to keep code clean in the long term. There's still one shortcut, which is notifications, because they break the architecture. Once you introduce notifications, they spread everywhere, and my recommendation is don't use notifications. Use direct patterns like delegation or observation instead. Okay, how does it work? We use CocoaHeads, and to maintain this, that consists of this local pods folder. So we have the project itself, but with pods located inside the project directory. And every framework has project file itself and an example. So the great thing is you can develop and test features per framework, and you can add an example app, an example UI to one of these example apps. So to test your implementation. You don't have to implement the UI in your real application. You have this example app and can play with it and explore and refine your API. It's a bit complex to set up in your project and on the CI server, but it's really rewarding. And a nice thing is also CI times are faster because only changed frameworks are tested. So we get quicker CI turnarounds. Testing is still pretty important to us, and we still think we want to force every developer to write new code, but what's the right barrier here? And we dropped the fixed barrier, but have a flexible now, and the rule is, if the coverage drops by 0.5%, this is okay. So, minor changes are forgiven, but if you add a complete class without tests, you have to write tests in order to make the build green. So that's really working well for us. Yeah, we tried a lot, but this is the best thing we can reach. But if you want to have everything tested, you need testable code. And our recipe is, the thing we like is to have protocols everywhere. And we do it like the Java guys. We have one protocol for every public interface and one implementation class for production. And if you need a mock, you just write a super simple class that just implements the protocol. And now mocking is super easy. And mocking is done using plain objects. Here's an example mock object that conforms to some protocol. And the only thing the method is doing is counting how often the method was called. And this is really helpful because sometimes this is an important information. Maybe your implementation is calling the method too often. So with just a boolean, you would not catch this problem. And using this technique, we can test pretty complex interactions between multiple classes, and that was not possible before. So, okay, your architecture is solid, your code is testable, you're writing tests. What else? Yeah, automate everything. And the compiler is your friend. Let the compiler help you. Switch on all warnings, enable everything on CI that is available, like static analyzer, switch on all sanitizers and memory guards available, and don't repeat yourself in code review. Set up a linter. Yeah, let the bots do the boring work for you. And as a result, the work is moved from the reviewer to the PR author. You don't have to start reviewing before the build screen. And this helps even in pretty small teams, because eventually the team will grow and new people will jump in, so you don't have to teach them everything from the beginning. They will just run into a red test and need to learn how to make the PR good and green. And consider writing UI tests, especially if you pay people to test your app manually. You should pay them instead to write UI tests. And you should automate everything. Here's what we are doing at the moment. This is a rack, QA lab, and we run tests from our CI on the target hardware. So basically on the right you see a speaker ripped apart and put in this case. And we can do all tests we need, like unit tests, performance tests, audio tests. Super important if you ship audio devices. And so we can test all aspects of the hardware. And we did this manually before. It was super expensive and took super long. You don't have to go that far if you're not in the hardware business. But there's still some things you cannot automate, like code review. So there are different opportunities or ideas what is code review, but for me, code review is staring at the code and ask questions. And you should really try to make sense of what you're seeing in the diff. And if you don't understand the code, ask. And spot testable but untested code and refactoring opportunities. And discuss style, typos, and comments spacing if you not have automated this already. And be really picky. Fight for the best possible quality. And in general, test code is also code, so it should be reviewed. And we have this principle of 6 eyes. So the first reviewer is yourself, as a submitter. So you just go through the diff and see if there's something wrong. Did you forget to remove test code or test logs? And then at least 2 people should have a look at your pull request and improve it. So look at the code and see, is it a bullshit test? Red alert. Does it make sense? Is it testing the right thing? Is it testing negative cases? Often people test only the positive case, but there are way more error paths and exceptions you should catch. And you should really focus on the details. Okay, last slide before pizza. How do I tell my boss? Typical, you invest more time in writing tests than implementing the feature. And it's really hard to sell to the management or to customers. So you have to fight for your rights, you have to fight for quality. So all estimations should include, of course, tests, API documentation, CI maintenance. And if some of these things you want to do are cut, then point out that the quality will suffer long term. And most important, make technical debt visible. You see it when you work with your code, but your manager, PO, CEO, UXI don't. So, typical phrases you should use: we implemented this feature in 3 weeks, but we spent most of the time because it's a bad architecture. Or we had to implement it twice for phone and iPad, watch, TV. And feature X caused a regression, which took 2 weeks to fix because we had no tests. So, share these numbers with the management and make sure everybody is aware of the problem. Repeat, your input is valuable. Management sometimes has no idea. They just see how long it takes, but they don't know why. And don't blame people, blame things. So, instead of a lot of questions, I have one question for you. How did you fail? Maybe you want to share your experience or learnings now in public or later when having pizza or beer. So, thanks.